So I'm a software engineer at Fleet Space Technologies. We're a startup in Adelaide. We do nano satellites, doing IoT communications for remote areas. And we've got 4 satellites up at the moment, launched last year. They're about sort of tissue box sized. And the flight software for those was in C. And so we have an opportunity for our next set of satellites to do something different. And currently writing the next version of the payload software in Golang. The reasons for that, rather interesting. The biggest one, honestly, was speed of prototyping. We're interfacing with a whole bunch of different hardware for the radios. And so an example, we've got a Semtech chip, which we need to communicate with over SPI. And we were able to get a demo up and running to transmit with this chip in about half a day. And if I had done the same thing in almost any other language I have used, I've done most Python, C, other web languages, which are obviously no-goes, probably would have taken closer to a week. So that was a very, very nice demonstration of just how quick we'll be able to iterate when we're using Go for something like this. Another big choice for it was we're needing to do simultaneous communications to multiple bits of hardware. We're talking to, let's say, 30 odd devices on the ground simultaneously with 30 different chips on this satellite. So having channels with all them coming in and then having a single place to process them. Channels makes that a lot easier than trying to do async I/O in Python or write threads manually in C. No. Yeah. That was just a brief thing of, hey, we want to put some Gophers into space. So, yeah.
So, yeah, I'm a little bit of a programming language geek. I think people say programming language nerd. I mean, look, I'm enrolled in a PhD program doing programming language design. Kind of a, you know, I found literally a year ago today, 2 worlds collided. The world, and Chewy knows this because I called him. It's like I knew he would understand. And he did, thank you. So the 2 worlds that collided was I realized that the options mechanism in protocol buffers is a thing called a meta-object protocol. We'll drop the object because it's just a meta protocol. So it allows you to define, you take a schema, which is your protocol buffer, and then you write options, which is a value that conforms to that protocol buffer. And this 2-language trick allows you to write schemas for schemas for schemas for schemas for schemas. My head explodes at about 5 levels of meta, 4. So I don't know where you'd push this, but in 30 years' time, I hope that we have like 12 that we know of, because this is literally going to, I'm quite confident to say that the single biggest problem in software engineering today is that we write too much code. And what I mean is that the ratio of specification that we write to code that we write, like specification is a pimple, and implementation is like everything. And you know, we run into all sorts of things. Prove that these 2 programs do the same thing. Prove that my program finishes. Prove my program doesn't have a race condition. And I'm not a type wonk. Chewy keeps telling me, so I'm picking on him. Chewy keeps telling me, why don't you program in Haskell? I say, well, I don't know Haskell. I didn't learn that. Like, you know, I actually tutored Haskell at uni. I don't know how. That was a long time ago. We swapped from Miranda. But this lightning talk is to some degree a segue into Roger's talk. And the cult that I want to start the purpose of it is that we must kill Jason and YAML. So, and what I'd suggest is that go and have a look at protocol buffers. It's not the only one that does this trick, but in effect, it's an inordinately simple type system. You've got structures and unions, and you've got annotations that are type safe. And that's all you've got, basically. And go and have a look at it, because if you can start pushing your specification into the options section of protocol buffers, and you write little engines that understand those options, the whole thing becomes human. Actually becomes humanly readable. So I would suggest go and have a look at. There's a number of these things out in the world. We've given them a title, which we call these things Tron, which is type respecting object notations. Okay, and if you don't like that and you want to say it another way, well, so there's a long history to it, and give me a couple of drinks, and like you won't hear anything else but that. Yeah, you can ask some people down here. Like my voice is hoarse because like this was all I spoke about last night. But that was okay. So yeah, I don't think I'm going to make a good cult leader. But you know, Tron, true on, mate.
So we're part of the same cult. At Safety Culture, we love protocol buffers. We use protocol buffers everywhere. We use it for our messaging in our Kafka systems. It's all protocol buffers. And so for service to server, it makes sense for us to use gRPC. If you don't know what gRPC is, it uses protocol buffers on the wire over HTTP2. But we still, at our API gateway, we were doing this crazy thing where everything was still in JSON. And because we're part of the same cult, we hate JSON. We don't want to be using JSON. It's a slowdown. It means we have to do this translation. So we decided to use gRPC everywhere. And so we actually use those protocol buffers to generate our clients, not only for all of our Go services, but we also generate for all of our mobile client. We do that in C++. We have a C++ layer. And we also generate gRPC web. So we even use it on the web for our communication too. Because this is a Go talk, I don't want to go too much into gRPC, but I just wanted to give you some insight. This is the kind of diagram to one of our Go services that our API Go services looks like. We have a single port that we have that listens over HTTP 1 and HTTP 2, so we have to use TLS for that. And we have a web server that listens there. We make a decision on where we should route that traffic. So if it's HTTP 1, we'll send that to a gRPC gateway that will convert the JSON payload into protocol buffers. It will then internally talk to the gRPC server and then basically call our gRPC interface. What's really cool about this is everything inside of the dotted lines, it's all auto-generated. We can auto-generate that for our engineers really, really quickly. We don't have to write all this code ourselves. And so our engineers can concentrate on the yellow bit at the bottom, which is the business logic. This is super, super powerful for us. It means we can get up to speed really quick and generate everything that we need to. And we have that strong contract using protocol buffers and gRPC. And we can maintain forward and backward compatibility all for free, pretty much, and which is super awesome. If you want to learn more, come and speak to any of the guys from Safety Culture. We'd love to chat to you about our tech stack and how we're using Go to save lives. Thank you very much.
Okay, so my name's Tim Adam. I'm a staff software engineer at Flexera in Melbourne. And I'm talking about Goa. So Goa is an open source project that we've been using quite a bit. It's 1.0 came out 3 years ago now, and we're up to 3.0 that has Go module support. It's come out a couple of months ago. We have a number of teams in Flexera that are developing solutions in various spaces for our customers that need to integrate and talk to each other. So we use Goa to specify our APIs in a domain-specific language that's valid Go code. So Goa provides a holistic approach for developing remote APIs and microservices in Go. So it has three pieces of in Go. I guess it's got three parts. It's the DSL. As I said, it's valid Go code. It's the code generator tool that reads that, and then it's a set of library packages that are used by both the generated code and by your business logic. So the code generator will generate all your marshalling, all your gRPC and HTTP transport independent communication, and it will also generate example client and server code that you can generate that once, and then you can start building your service. So just like I think it was Roger just before had the diagram up there with the business logic down the bottom. Yeah, that's Goa provides a lot of that as well. So I guess it's similar to that. We write our business logic, and we don't have to write. We generate all what's up above. So we start with our. I guess the difference is we start with our DSL and regenerate as necessary the top part, and so whenever, for example, your design changes, or whenever whenever the Goa version changes, for example, you can regenerate and not have to maintain all that code. We can generate an open API spec from the design as well, so we use that for communicating our designs between the teams. It supports HTTP and gRPC protocols. It supports our consistent approach to design of microservices. So we start with the design, we get that reviewed, we build the shell service that runs end to end but with no functionality. Then we can add functionality later. So it supports our method of development. And maybe a little bit about the DSL. It's quite fully featured. You can describe the input and output encodings. You can give field validations for all the usual types. You can define the errors, including custom error types, and it supports also streaming payloads and results, as well as the once-off request and response in both gRPC and HTTP. And so for more information, go to the website at...
What is the website?
It's goa.design.
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 Cool.
Or there's also the Goa Design github.com/Goa Design.
Cool. Thank you.
Thank you.